Imagine the moment after the last heartbeat of the universe. Silence, not empty, but alive with waiting. Galaxies hang like frozen lanterns. Waves of light, once racing across the cosmos, now stand still, as though caught mid-breath. Time itself has stopped. But could that ever truly happen? Could the very fabric that weaves every second, every motion, every thought, simply fade into stillness? We live our lives inside time, yet we rarely see it. It's the invisible pulse behind all creation. It flows through galaxies and through our veins alike. It measures the birth of stars and the blink of an eye. But what if time is not infinite? What if, like all things, it too has an end? From the smallest atom to the largest cluster of galaxies, everything moves in rhythm, expanding, vibrating, decaying. That motion gives time its direction. But if the universe one day loses that rhythm, what happens to time itself? In physics, time is not just a ticking clock. It's part of the structure of reality, intertwined with space, forming what Einstein called the space-time continuum. Yet even Einstein hinted that this structure could bend, stretch, and maybe break. Perhaps time is not an endless river, but a loop, or a spiral, or even a dream. One that began with a single spark and may end with a single sigh. Philosophers have long asked whether time exists independently, or whether it's something we create through perception. The ancient Stoics believed time was the heartbeat of the cosmos, ever living, ever cycling. But if cycles can repeat, they can also conclude. And so, we must ask, if the universe were to stop expanding, if every atom fell into perfect stillness, would time itself come to rest? Would the final instant of existence stretch into eternity? Or perhaps, beyond that stillness, there lies another kind of time, a dimension we cannot yet imagine. The clock ticks, galaxies turn, and we go on counting seconds as if they were eternal. But what if one day, there are no more seconds left to count? What would it mean not for time to pass but to end? Could there be a moment when the universe exhales for the last time, and in that breathless pause time itself stands still? Since the dawn of consciousness, humanity has tried to understand the flow that carries us forward, the current we call time. Before the language of science, before the ticking of clocks, time was measured by the turning of the sky. The rising sun, the phases of the moon, the migration of stars. These were our first calendars, our first reminders that existence unfolds in rhythm. In ancient Sumer, priests stood on ziggurats and charted the heavens. Each dawn was a rebirth, each dusk a quiet death. They saw time not as an endless line, but as a sacred wheel, a divine order that turned with celestial precision. To the Egyptians, time was eternal recurrence. The sun god Ra sailed his golden boat across the sky each day and descended into the underworld each night, only to rise again. Their word for time, Nihe, meant both renewal and eternity. For them, time was alive, breathing, cycling, infinite. Meanwhile, the Greeks saw time through two faces, Chronos and Kairos. Chronos, the steady ticking of measured time, the minutes and years that carve our days into patterns. Kairos, the opportune moment, a living instant that carries meaning beyond measure. To them, time wasn't just numbers, it was quality. A perfect moment, a chance, a convergence of meaning. The Mayans built temples that aligned perfectly with the equinoxes, encoding within stone the heartbeat of the cosmos. Their long count calendar didn't simply mark years. It tracked ages of creation and renewal, vast epochs that rose and fell like breaths of the universe. They believed time was cyclical, spiraling through creation and destruction, forever repeating, forever reborn. Even in the East, philosophers pondered the nature of time. In India, Kala was both the god of time and death, because in the movement of moments lies transformation. Time was the dance of Shiva, the endless rhythm of creation and dissolution. And in China, the Taoists spoke of time as the flow of the Tao, the natural unfolding of existence. To resist time was to resist life itself. For all their differences, these ancient cultures shared a strange wisdom. They did not see time as an enemy, or even as a straight path. They saw it as a living circle, one that connects all things, from the birth of stars to the fall of empires, from a single breath to eternity. Then came the sundial. For the first time, humanity could slice the day into hours. Shadows became our first instruments of measurement. Water clocks followed, dripping seconds into vessels of memory. In those slow, deliberate drops, time became quantifiable, divided, ordered, controllable. And with that, something changed in us. We began to see time not as a flowing mystery, but as something to use. We began to live by it, to race against it, to fear losing it. The sacred river became a schedule. The eternal now became the past, the present, and the future, each one separated by the thin veil of expectation. Yet, even as our civilizations evolved, the questions remained the same. What is time made of? Is it a thing that exists outside us, or a pattern we create within? In temples, in observatories, and in the quiet corners of our minds, humanity has always felt the pulse of time, even before we understood its science. We've built monuments to its passing and myths to its mystery. Perhaps time is not a prison, nor a ladder, but a mirror, one that shows us not where we are going, but what it means to exist at all. And so we must ask, if ancient people saw time as a circle and we see it as a line, which of us is closer to the truth? What truly is time? Not the ticking of clocks or the turning of calendars, but the essence beneath all change. The silent dimension in which motion, memory, and meaning unfold. Scientists once believed time to be absolute, a steady beat that governed all things equally. But the deeper we looked into the universe, the more it revealed a strange secret. Time is not the same everywhere. In 1905, Albert Einstein rewrote our understanding of reality. He showed that time and space are not separate entities, but threads of a single fabric spacetime. And in this cosmic tapestry, motion stretches the threads. Gravity bends them. Time itself slows down or speeds up depending on where you stand and how fast you move. A clock aboard a spaceship, moving near the speed of light, will tick slower than one on Earth. To the traveler, time flows gently. To those left behind, it races forward. Both are correct. Both are true. In Einstein's universe, time is not a universal rhythm. It's a local melody. This realization shattered centuries of certainty. No longer could we speak of now as something shared by the cosmos. There is no single present moment. Each observer carries their own version of reality. Time, it seems, is woven into the way we see. But there is something else, something that gives time its direction. It's called entropy. Imagine a glass shattering. You can replay the moment forward and backward in your mind, but in nature, it only happens one way. The glass does not reassemble itself. Why? Because entropy, the measure of disorder, always increases. This is the arrow of time. Entropy gives time its meaning, its irreversible flow from past to future. It explains why we remember yesterday but not tomorrow, why eggs break but never unbreak, why the universe seems to move toward chaos. And yet, the laws of physics themselves are timeless. Equations describing particles and energy don't care which way time moves. They work just as well backward as forward. So where does this arrow come from? Why does the universe prefer one direction over another? Some scientists suggest that the answer lies in the universe's birth, the Big Bang, a moment of perfect order from which disorder has been growing ever since. The entire history of time might simply be the universe's slow journey away from that original symmetry. Others see it differently. Perhaps time doesn't truly flow. Perhaps it's all there already, every second, every moment, existing together like pages in a book. We move through them, one by one, and call that movement time. This is the block universe theory. The past, present, and future coexist eternally. Nothing truly happens. Everything simply is. Yet our minds rebel against that stillness. We feel the flow, the pulse of now, the unfolding of possibility. Could this sensation be an illusion, born from consciousness itself? Or is it proof that time is not merely a property of the cosmos, but of life within it? Physics tells us that time is relative, elastic, and inseparable from space. Thermodynamics gives it a direction, an arrow, and yet, both struggle to explain the simple mystery. Why does time exist at all? We are left with paradoxes, beautiful and unsettling. If time can slow down, can it also stop? If the laws of physics don't need time to function, why do we experience it so vividly? The deeper science looks, the more time dissolves into something almost mystical. A shadow of motion, a whisper of change, a dimension that might only exist because we do. So what if the universe doesn't move through time at all? But time moves through us. To understand the mystery of time, we must go back to the moment when there was no before. Before stars, before matter, before light itself. There was only potential, a silent sea of pure possibility. Then, in a single, unfathomable instant, something extraordinary occurred, the universe awoke. We call that moment the Big Bang. Not an explosion in space, but the birth of space and of time itself. From a dimensionless point smaller than a grain of sand, reality unfolded, carrying with it the very first second. That first second was not measured by clocks, for there were none. It was measured by change, by the heartbeat of creation beginning to pulse. The early universe was a storm of light and energy. Temperatures soared to unimaginable heights. Particles collided, fused, and separated in a cosmic dance. Out of that chaos came order. As space expanded, energy cooled, and the first building blocks of matter took form. In that brief, radiant age, time itself stretched like a newborn's breath, growing, expanding, unfolding. Physicists describe it as the inflationary epoch. Within a fraction of a second, the universe grew from smaller than an atom to larger than a galaxy. In that expansion, time was born. Before the Big Bang, the question "what came before?" loses meaning because before implies time, and time did not yet exist. The universe was not born in time. Time was born with it. Every star that burns, every planet that spins, every thought we think. All of it unfolds upon the tapestry that began with that first cosmic heartbeat. Space and time are inseparable, flowing together like the threads of a single cosmic fabric. Where space bends, time bends. Where gravity deepens, time slows. The very shape of the universe determines how time itself passes. As the first atoms formed and light began to travel freely, the universe transitioned from opacity to brilliance. The cosmic microwave background, the faint afterglow we still detect today, is the first visible memory of time itself taking form. In that gentle radiation, we see the echo of the moment when time first gained direction. Yet this raises a question as beautiful as it is bewildering. If the universe began with time's creation, will it also end when time runs out? Some cosmologists imagine the universe as a closed loop, destined to contract after its grand expansion, collapsing back into itself in a big crunch. In that final moment, time might rewind, folding all history back into a single, timeless point. Others envision eternal expansion, galaxies drifting endlessly apart, stars burning out, energy dispersing until motion itself ceases. Whichever future awaits, it all began with one breath, the first motion of time. Even now, as you listen, the universe continues to expand. Space stretches between galaxies. The cosmic clock keeps ticking. And yet, the further we look into the past, the closer we get to the beginning, until, at the very edge of understanding, time itself blurs into something unknown. Scientists can describe what happened a trillionth of a second after the Big Bang, but not what happened at the moment itself. Because at that singularity, our equations fail. Time, space, and energy dissolve into a mystery beyond measure. Maybe the birth of time was not a single explosion, but a transition, from timelessness into rhythm, from stillness into becoming. Perhaps, even now, the universe is still learning how to be. And so, the question remains, if the universe began with time's first heartbeat, what will it sound like when that heartbeat stops? The universe began with motion, a great exhale that set everything into flight. From that first luminous instant, time has flowed ever outward, carried on the expansion of space itself. But what if that flow were to slow, and someday stop? Every galaxy is moving away from every other. The further we look, the faster they recede, stretching the light they emit into longer and redder wavelengths, a cosmic echo of their flight. For most of history, scientists believed that gravity, the silent sculptor of the cosmos, would eventually pull everything back together. The Great Expansion would slow, reverse, and end in a grand collapse, the Big Crunch. But in 1998, astronomers made a discovery that changed everything. They found that distant galaxies were not merely moving away, they were accelerating. The universe was not slowing down. It was speeding up. Something unseen, something vast and invisible, was pushing it apart. We call it dark energy, a mysterious force that fills all of space, driving galaxies away faster with every passing moment. It accounts for nearly 70% of the universe's total energy, yet no one knows what it truly is. Dark energy is not simply expansion. It is the expansion of expansion. It stretches space-time itself, carrying with it the rhythm of time's flow. And if dark energy continues to dominate, then time as we know it may not end in a crash, but in a long, fading whisper, the quiet cooling of eternity. Still, there are other possibilities. Some cosmologists believe dark energy could change. Perhaps it will weaken one day, and gravity will regain its hold. The expansion might slow, stop, and reverse, turning outward motion into inward motion. In that moment, the arrow of time might bend back upon itself. Imagine a future where galaxies no longer drift apart, where cosmic expansion halts in perfect balance. Light would stop stretching. Motion would still. Every atom, every wave would linger in quiet equilibrium. What would that feel like? Would time itself pause? A universe holding its breath between two eternities? Einstein's equations suggest that time and motion are deeply bound. When the universe slows, so too might the flow of time. If space stopped expanding altogether, the very geometry that allows time to move forward could flatten into stillness. There would be no change, no movement, no entropy, and without change, time loses its meaning. Some theorists even whisper about cosmic freezing, a scenario where the acceleration of the universe eventually stretches everything, even atoms, until motion ceases altogether. In that far-off horizon, every vibration would fade, every heartbeat of matter would calm, and the measure of seconds would dissolve into silence. And yet, there is a haunting symmetry to this vision. The universe began with a burst of motion, the Big Bang, and may one day drift into a tranquil stillness, a mirror reflection called the Big Chill. It is strange to think that time's flow depends on the universe's expansion, that every second we live, every thought, every dream, is the unfolding of space itself. If that unfolding were to slow, our experience of time might stretch, moments growing longer, days unfolding like eternities. Would consciousness feel the difference? Would a single second last forever if the cosmos itself paused between breaths? Perhaps, in that stillness, the universe wouldn't die, it would transform. Maybe time does not end by stopping, but by changing form, turning into something beyond motion, beyond perception, beyond even physics. If the expansion of the universe slows, and the music of galaxies begins to fade, will time stop altogether? Or will it simply learn a new rhythm we have yet to hear? Every fire fades, even the fire of creation. The universe, though vast and radiant, is not eternal in its warmth. It began as a sea of energy, dense, bright, alive. But each star that burns, each galaxy that glows, contributes to a quiet truth. The cosmos is cooling. Slowly, inevitably, it drifts toward stillness. This vision is called the heat death. Not a violent end, but an ending of silence, a spreading calm that will one day cover everything. It is the final destination of entropy. In this far future, the stars will exhaust their fuel. Their light will fade into red embers, and then into darkness. The galaxies will no longer sparkle with birth and renewal. Black holes will swallow what remains of matter, only to evaporate themselves into nothing but faint radiation. Time will continue to move forward, but there will be less and less to mark its passage. No rise, no fall, no change. And that is the paradox. If nothing moves, if nothing transforms, can time still exist? Entropy, the arrow of time, is driven by difference, by contrast, by imbalance, by the transfer of energy from one form to another. A hot object cools. A star burns out. A thought flickers and fades. All these are small echoes of the universe's grand equation. When that equation reaches perfect balance, when there are no differences left, the arrow of time no longer points anywhere. In the ultimate equilibrium, the cosmos becomes uniform. Every atom spread thin across space. Every temperature equal. Every energy exchanged. A sea of absolute stillness. It will not be darkness in the sense of night, for night implies contrast, a place where light might return. In the far future of the cosmos, there will be no contrast left. No stars to rise, no shadows to fall. Just an endless, luminous quiet. Physicists estimate this may occur trillions upon trillions of years from now. A span so immense that even language trembles before it. Yet, in this cold infinity, time itself becomes uncertain. Without change, without heat, without motion, there can be no before or after. The very definition of time, the measure of transformation, dissolves. And here lies a profound thought. Perhaps the end of time is not a sudden event, but a gradual fading. A dimming of the universe's pulse until it becomes indistinguishable from stillness. Time may not stop. It may simply lose its purpose. In that final calm, physics and philosophy meet. Some suggest that beyond the heat-death lies rebirth, a quantum fluctuation so rare and vast that it could spark a new Big Bang, igniting a new universe, a new arrow of time. Others believe the stillness is complete, the eternal rest of all things. But perhaps the truth is deeper still. Maybe time is not bound by the cosmos at all. Maybe, when the last atom cools and the final photon fades, what remains is not nothingness, but awareness itself. For even in a universe without change, there may exist the memory of movement, the silent echo of every moment that ever was. In this ultimate stillness, time may not be gone, only transformed, like a melody that continues after its final note has faded. And so we must wonder, when the universe reaches perfect stillness, will that be the end of time, or the beginning of something beyond it? In the world of the very small, the world of atoms, quarks, and quantum fields, time begins to lose its meaning. Here, reality doesn't unfold in a steady rhythm. Instead, it flickers like static between channels. Particles appear and vanish, dance and dissolve, not in sequence, but all at once. The quantum realm doesn't follow the clockwork of our human perception. It hums to a different tune, a melody without tempo. At this level, the familiar order of cause and effect begins to blur. Particle can exist in two places at once. An event can influence another that hasn't yet happened. The boundaries between past and future ripple, uncertain and reversible. Time in quantum mechanics is not a river, it's a fog. Physicists have spent decades trying to make sense of this strangeness. When we step into the quantum domain, Einstein's smooth fabric of spacetime starts to fray. The universe, which on large scales seems continuous and predictable, becomes granular, probabilistic, and utterly mysterious at its foundation. Some interpretations go even further. They suggest that time does not exist at the quantum level. The Wheeler-DeWitt equation, a cornerstone of quantum cosmology, describes the entire universe as a single wave function, a mathematical expression of all possibilities. But strangely, in that equation, time disappears. The universe is static, complete, already whole. In this view, what we experience as time may simply be our movement through a timeless quantum landscape, each moment a different configuration of the same infinite whole. It's as if all the pages of existence already exist, and consciousness is the act of reading them, one by one. Carlo Rovelli, a modern physicist and philosopher, puts it beautifully. Time is born from our ignorance of the world. In his theory of loop quantum gravity, space and time are not continuous. They are made of discrete, indivisible loops woven together like a cosmic tapestry. Within these loops, there is no flowing time, only relationships between events. Time, he suggests, is not something that is, it's something that emerges. At the smallest scales, even the difference between before and after becomes uncertain. Quantum experiments show that particles can be entangled across time, their states linked in ways that defy sequence. One measurement in the present can retroactively define what was true in the past. The universe, it seems, does not wait for us to decide when now begins. So what happens when we apply this quantum timelessness to the cosmos itself? If the universe at its foundation is timeless, then perhaps the Big Bang was not the beginning of time, but the moment when time became visible. The unfolding of temporal order may be a kind of illusion, a byproduct of complexity, born as consciousness began to observe itself. In this sense, time may be more like a story that reality tells itself to make sense of its own patterns. Each quantum vibration, each fleeting particle, contributes a syllable to the grand sentence of existence. The narrative of before and after might not be a fundamental truth, but a translation, a way our minds interpret something far more intricate. And yet, this vision is not cold or mechanical. It is deeply poetic. It means that everything that ever was and ever will be is already written into the quantum fabric of being. We are not travelers moving through time. We are awareness illuminating different parts of an eternal whole. So when we ask, what happens when time stops? Perhaps the answer is not an end, but a revelation. For in the quantum world, where stillness and motion coexist, the flow of time is neither lost nor broken. It simply becomes irrelevant. If at its deepest level the universe is timeless, then what is this feeling we call now? If time in the quantum world can vanish, then why do we feel it so vividly? Why does every moment seem to slide into the next, carrying us forward on an invisible current? The answer lies not in the stars or equations, but within the quiet folds of the human mind. To our brains, time is not an external clock. It's a construction. Neuroscientists have discovered that what we perceive as the present is not a single instant, but a small window, about 3 seconds wide, within which the brain gathers sensory input and stitches it into a seamless experience. In other words, what we call now is already the past. Our consciousness lags just slightly behind reality, editing it into a story we can understand. The philosopher Augustine once wrote, "What then is time? If no one asks me, I know. If I wish to explain it, I know not." He sensed what modern science is only beginning to confirm. Time is not something we see, but something we feel. Our brains translate motion, change, and memory into a linear narrative, giving us the comforting illusion that we are moving from then to now to later. But in truth, everything we experience, memory, anticipation, awareness, is happening in a single eternal present. When you recall your childhood, your brain reactivates the same regions that lit up during the event itself. You are not visiting the past, you are recreating it moment by moment. The mind doesn't store time, it reimagines it. This is why time feels elastic. When we are bored, seconds stretch endlessly. When we are in love or lost in awe, hours evaporate. Time doesn't change, we do. Our internal clock expands and contracts according to emotion, attention, and presence. The physicist's time, cold, steady, mathematical, is not the same as the time of the human heart. In dreams, this becomes even clearer. A single night's dream can feel like days or years of experience. Entire lives can unfold within minutes of REM sleep. Our sense of duration is woven entirely from perception, a psychological rhythm rather than a physical one. Perhaps this is why mystics and philosophers across cultures speak of the eternal now. In moments of deep meditation, awe, or creativity, the boundary between past and future dissolves. Everything seems to happen at once, as though the mind has stepped outside the current of time. The poet T.S. Eliot wrote, "At the still point of the turning world, there the dance is." Could it be that time's flow exists only for those who resist stillness? That in the vast quiet of complete awareness, time reveals itself not as a movement, but as a state, a timeless unfolding of being? Even neuroscience hints at this. Some experiments suggest that consciousness arises in discrete pulses, small bursts of awareness flashing several times per second. Between these pulses, there may be moments of nothing, tiny gaps in which the world does not exist for us at all. Yet when the brain connects these pulses, it creates the illusion of continuous flow. Like frames in a film, reality feels smooth, but it may, in truth, be flickering. And so, perhaps we do not live in time, we create it. Each thought, each sensation, each heartbeat constructs a personal universe of before and after. We are time's architects, shaping eternity into sequence. If that's true, then when the body grows still, when the mind falls silent, and the story of moments ceases, does time itself disappear with it? When no one is left to count the seconds, does the universe still keep time? If science shows us that time may not be fundamental, then philosophy dares to ask, what remains when it is gone? From the earliest thinkers to the quiet mystics, humanity has always wrestled with the idea of eternity, not as endless duration, but as existence outside of duration. For what is eternity, if not a state in which nothing needs to begin or end? To Plato, time was the moving image of eternity. He imagined eternity as the still perfection of the divine, and time as its shadow motion projected upon the walls of creation. In his view, eternity doesn't unfold. It is. Aristotle, more pragmatic, saw time as the measure of change. Without movement, without transformation, there could be no time at all. But he too suspected that beyond motion, something unmoving must exist. A pure reality untouched by change, timeless and complete. Centuries later, Augustine would look inward and find eternity not in the heavens, but in consciousness itself. The present of things past is memory, he wrote. The present of things present is attention. The present of things future is expectation. In other words, past and future exist only as facets of the mind. Eternity, then, is the infinite depth of the present moment, the space in which all of time is contained. Buddhist and Hindu philosophies echo this truth in another tongue. The eternal is not a duration to be measured, but a condition to be realized. Samsara, the cycle of birth, death, and rebirth, is time's endless wheel. Nirvana is the moment you step off that wheel, not by halting it, but by awakening to the fact that it was never moving at all. Modern thinkers, too, have gazed into this paradox. Martin Heidegger asked whether time is the essence of being, or whether being gives rise to time. If the future, the past, and the present are only structures of human existence, then perhaps the end of time is not a cosmic event, but an awakening of perception. And the poet-philosopher Blake once wrote, "Eternity is in love with the productions of time." Could it be that time and eternity are not enemies, but partners? That one gives motion to meaning, and the other gives meaning to motion. Imagine existence without time. No ticking clocks, no unfolding stories, no anticipation or regret. There would be no when, only what is. Every possibility, every moment, every being existing simultaneously, intertwined like colors in a single beam of light. If such a state exists, then we, beings of time, are its expressions. Each of us a ripple on eternity's surface, momentarily rising and falling, yet never truly separate from the still ocean beneath. Perhaps eternity isn't the absence of time, but its source, the silent wellspring from which the river flows. Time may be eternity's language, a way for the infinite to experience itself in fragments. And so, the question shifts. The end of time may not mean the death of existence, but its return to wholeness. When the last second dissolves, when the arrow of time folds back into its source, what remains might not be nothingness, but everything all at once. If eternity is not endless time but timeless being, then are we living in time, or is time living through us? Perhaps the end of time is not an ending at all. Perhaps it is a moment of transformation, when the universe exhales the last of its movement and becomes aware of itself. When the clocks stop not in silence, but in understanding. Imagine it. The final star flickers, its light stretching into an endless horizon of calm. Space no longer expands. Matter no longer stirs. What was once motion becomes stillness. And in that stillness, the rhythm we once called time returns to its source. But maybe, just maybe, that is the beginning of something far greater. In the great cosmic cycle, creation and dissolution are not opposites. They are reflections of one another. The Big Bang was not the universe's first breath, but one of infinite inhalations. If time was born in that moment, it can also be reborn in another. Eternity might not be a straight line or even a circle. It may be a pulse, forever beating in the dark heart of existence. The end of time, then, may be the instant when time dissolves into consciousness. when there is no longer before or after, only pure awareness of being. A state where the universe knows itself not as a sequence of moments, but as one vast, unbroken whole. Even now, in fleeting moments of awe, when we look up at the stars, when music moves through us, when we lose track of the hours, time loosens its hold. We touch the edge of the eternal, a space where past and future vanish, and only the now remains. Perhaps these moments are not glimpses of illusion, but echoes of truth. The truth that beyond time, there is presence. For billions of years, time has shaped everything, the birth of galaxies, the rise of life, the unfolding of thought. Yet, as physics and philosophy converge, we begin to see that time may not be the ultimate ruler of reality. It may simply be one of its expressions. The universe may not end when time ends. It may simply awaken to a deeper mode of existence, one that does not depend on sequence, or change, or decay. If the arrow of time were to vanish, what would remain? Perhaps not emptiness, but harmony. Not nothingness, but wholeness. The same essence that existed before the first moment, waiting patiently for awareness to recognize itself once more. So maybe time does not die, it transforms. Like ice melting into water, its form disappears, but its essence continues. What we call the end of time might be the return of timelessness, the silent home from which all things emerged. And so, as we stand here, surrounded by the ticking of clocks and the turning of worlds, we can ask one final question. If one day time stops, and the universe becomes still, will that be the end of everything we know? Or the moment when we finally remember what we've always been, eternity itself?